Hey, welcome back to the Computer Hardware and OS Essentials lecture series. I created these custom lectures based on A+ certification program with few enhancements to improve your IT technical skills and knowledge. So if you haven't seen my previous videos, I will post a link in the description for the playlist. This would be our 5th lecture and we will go over random access memory or RAM. So the primary objective of this lecture is to learn what is RAM, how does it work, the different types of RAM when it comes to the point performance and features, and we will go over a little bit about server RAM, which is ECC, buffered or registered RAM, memory channels, and finally we learn about how we can install RAM. So what is RAM? So let's take the term random access memory or RAM and break it into two pieces. So the RAM is random because RAM can be read and changed in any order, and a random access memory device allows data items to be read or written in almost the same amount of time, irrespective of the physical location of data inside the memory. So basically it is random because it allows you to read and write to it without any specific sequence. So it can be randomly written or read from its memory. We call it memory because RAM is a type of volatile memory, meaning that the data stored here is lost when power is lost. And this type of memory is like short-term memory of a human, and so you only need to access it while working with it. So the reason why we call random access memory, because you can access it randomly, read or write randomly, and we call it memory because it's a type of volatile memory, and that is used for quick access of data. And as you can see, this is just a joke. It's not this type of RAM and it is not this type of RAM. This is computer RAM that we are talking about right here. I hope you know that by now. So it's just a quick joke. So let's look at how it actually works. So RAM works like your desk. So imagine you have a table, right? So while you're working on task, the more desk space you have, the more bits of paper you have out in the open on your desk. So RAM works exactly like this. So when you have multiple programs open and working, they are all taking up space in your RAM. So the reason why you would have a desk like this shown here maybe because you believe, or in this case you are probably having an efficient way of working this way as opposed to have it file it away. So imagine you have all of these papers on your desk filed away in a neat folders. It may be more time consuming to go to those drawers and pull those papers out as opposed to having all those documents out in the open. So while you're working with those documents, you have those documents out on the open on your desk, making it easier for you to access those documents. Just like that, the RAM does the same thing. When the multiple programs are open and working, it's going to store the data related to those programs on the RAM so that it is easier and faster to access it, just like having a desk with a whole bunch of documents that you're working on. It is very fast storage space for temporary data processes and applications that are being worked on. So just like having it out in the open on your desk, it is faster to access data on a computer that is stored on a RAM as opposed to stored on a hard drive, for example. So RAM gives you extremely fast access to data that is currently being accessed or worked on, just like this desk analogy. So as opposed to having filed away on a hard drive, we are basically using the RAM to store data temporarily so that the applications and processes currently running can access this really fast so that it won't bog down your computer. So that's how the RAM basically works. This is basically a high level overview of how RAM is different from, let's say, permanent storage. So let's look at memory technologies. So RAM holds data and instructions used by CPU, while DRAM, also known as dynamic RAM, is what we add onto the motherboard as memory modules or sticks. So even your CPU has its built-in RAM, but what we actually install on your computer other than the CPU, those sticks we call dynamic RAM or DRAM. Random access memory, which is shortened RAM, is temporarily holds data and instruction used by CPU. So the RAM within the CPU basically gonna hold data and instructions that will be used by the CPU for processors, temporarily, just like a DRAM. The dynamic RAM or DRAM loses its data rapidly, and the memory controller must refresh it several thousand times a second. So keep in mind, when we are discussing RAM, typically with our clients or end users, we are talking about DRAM. We are not talking about the RAM itself that is being used by the CPU, but rather the RAM that we are putting in as stick modules. So keep that in mind. So variation of DRAM, which are the sticks or modules that we inserted into our motherboard, includes the DIMM, also known as dual inline memory modules or DIMM modules. These are used by desktop computers. And the other one called SO-DIMM. SO stands for small outline, and DIMM is basically dual inline memory. So small outline dual inline memory or SO-DIMMs are used on laptops, and micro DIMMs are used on sub-netbook computers. So these are basically a smaller form factor, smaller version of DIMM. You can look at that way, even though they are slightly different in terms of engineering architecture. So those are some variation of RAM, and there are more variations associated with this as well. So the D in DIMM stand for dual, RAM, right? So the duals, right? So the name for the independent pins on both sides of the module's edge connectors, and all DIMMs have 64-bit data path, so data lanes. You can look at that way. So the D in DIMM, so if in the previous slide, the D stand for dual inline. So what the dual inline actually doing is it is named for the independent pins on both sides of the module's edge connector. So if you look at the DIMM type of RAM, you see that the connectors on the both side of that pin setup. So all DIMMs have 64-bit data lane as a data lanes or data paths as a result. SIMM or single inline memory module is an older technology that has pins only one side, and in 2022 I haven't seen many computers with SIMM on it, like really old computers maybe on your side that you still have SIMM on it, but every single modern day computer does not have SIMM type of RAM because it is basically an older technology that is being phased out. DDR, which stands for double data rate, is a type of DIMM that is twice as fast as earlier DIMMs when it was invented. So DDR is a standard called double data rate, and that allow the DIMM to operate at a faster rate, faster frequency than the original DIMM modules that came out. Then there are several versions of DDR. Those are called DDR2, DDR3, DDR4, etc., etc. So the DDR2 SDRAM are faster than the previous DDR and use less power as well. So they are power efficient. And when you move on to the DDR3 SDRAM, it is going to be even faster than the DDR2, the previous generation, and it also uses much less power compared to the DDR2 previous generation RAM. The DDR2 and DDR3 use 240 pins, and you need to keep in mind that these are not interchangeable, so they are not compatible against each other. and use different notches. So if you have a motherboard that support DDR2, you wouldn't be able to install DDR3 even though they are using the same pin configurations, because of the notch would be in a different location. And I will go over a little bit of a notch in the next few slides as well, but keep that in mind. It is the DDR2, DDR3, all of those things cannot be mixed together. DDR4 is the next generation of the next iteration of the DDR RAM, and this is faster and uses less power than the DDR3, which is the previous generation. And this time we will be using 288 pins as opposed to 240 pins that you've seen in DDR2 and DDR3 modules, and has a single notch in the edge of the connector. So these are basically different iterations or newer generations of DDR modules. So we went from DDR to DDR2, DDR3, and DDR4. DIMM and SO-DIMM technologies. So factors that affect capacity, features, and performance of those DIMM modules or RAM modules includes the number of channels they use, how much RAM is on the DIMM, the speed, also known as frequency of the RAM, and error checking abilities, which are like used by the servers. Those are called ECC, and whether they are buffered or not, unbuffered. So we're going to go over that a little bit next few slides. So single, dual, triple, and quad channel. You may have heard these terms in marketing, materials on websites and even motherboard descriptions. So what do they actually mean, right? So early single channel DIMMs, those are memory controllers where it is access one DIMM at a time. So the memory controller can only access one RAM module at a time, even if you have multiple modules installed onto your motherboard. So you could have 6 single channel DIMMs, but the memory controller will only access one DIMM at a time. Which is kind of slower in a way compared to the modern day, right? Technologies such as dual channels, triple, and quadruple. So with dual channels, memory controller communicates with 2 DIMMs at the same time and doubles the speed of memory access as a result. So instead of now having access to one DIMMs module at a time, the dual channels will allow the memory controller to access 2 modules at the same time if it is properly installed. Triple channel motherboards can access 3 DIMMs at a time. So it is increasing now the efficiency and the speed. And when you go to quad channel, again, the motherboard increase the efficiency by now accessing 4 channels, 4 DIMMs at the same time. So increasing efficiency, and also this also increase the power usage as well, the power efficiency as well. So that is, so by going from single channel to dual to triple to quad, we are increasing efficiency not only in terms of accessing speed, but also power efficiency as well. The DDR, DDR2, DDR3, and DDR4 DIMMs use dual channels. DDR3 DIMMs can also use triple channels, and DDR3 and DDR4 can use quad channel. So if you are buying quad channels DDR memory, you are not getting DDR or DDR2. You probably gonna get DDR3 or DDR4, either or. You have to, because those DDR3 are the DDR3 and DDR4 are the only DIMM modules that can support quad channel. But keep in mind, your motherboard has to also support the quad channel configuration. Otherwise, it will just default down to whatever either dual or triple or single channel mode, whatever your motherboard is supporting. So you have to make sure whatever the RAM you are buying is compatible with the motherboard that you are trying to install. For dual, triple, or quad channel to work, remember, as I mentioned in the previous slide, the motherboard and the DIMM must support the technology. So the motherboard manufacturer typically color codes DIMM slots to show you how to configure dual, triple, or quadruple channels. And if you even don't have that information not color coded, or sometimes motherboard manufacturers put little letters on the motherboard like A, B, C, and then repeat A, B, C or A, B over and over, designating which is dual, which is quad channels that you should populate. If that's the case and you're confused about how the color code or the letters work, you should refer to your motherboard manufacturer's documentation, because documentation should describe clearly how it works. And again, I will show you an Intel documentation later in this slides lecture, so that you can have a better idea about how those documentation works, especially with respect to servers and stuff. So setting up dual channeling, you need to make sure pair of DIMMs in the channel must be equally matched in size, speed, and features. It is highly recommended that you use the same manufacturer when you are purchasing these dual channel configurations, because that way it will make sure that you have the highest efficiency and configuration compatibility on your motherboard, right, on your RAM. So make sure when you're buying dual channel, try to not to mix them up, especially with size, speed and features, but also try to buy it from the same manufacturers. The setting up a triple channeling, 3 DIMM slots populated with 3 matching DDR3 DIMMs. Even though this is not indicated on this slide, again, it is recommended that you use the same manufacturers to all 3 DIMM slots with the same speed, size, and frequency. One thing to note, I would also try to make sure that same batch number or same lot number is used for these dual or triple channels when I'm trying to install it on high efficiency enterprise servers, because enterprise servers with this type of dual quad channel configurations will benefit from having the best match option. So in that case, I would go out of the way to sometimes make sure the lot number and the serial numbers are next to each other for these triple or dual channel or even quad channel setups. So using dual channels, the memory controller can read from 2 DIMMs at the same time, as I mentioned before. So how it's going to work is we have the processor and we have the processor architecture within the processor package. So when you take the processor die or the chip, whether it's an Intel or AMD, you will have the processor itself, and then you have the bus, and then you have the memory controller, and that would be your processor. So if you buy it, for example, Intel i7 processor, that would have the processor, the bus, and the memory controller. Then how the processor going to interact with the RAM in this diagram is showing a dual channel configuration. It's going to have a 64-bit channel 2 here and 64-bit channel 2. So it's going to interact with slot 2, these two together. And then it's going to interact with the channel 1 with these slot together. So when you're populating it, you need to take into consideration how your processor's memory controller gonna interact with your channels. So in here, like, you need to look at how this should be populated based on this architecture. Matching pairs of DIMMs installed in 4 DIMM slots that support dual channeling is shown here. So how it's going to work is that the DIMMs in channel A slots work together. So channels A is this one and this one. So it's not right next to each other. It's one after. So with this one works with this one. So that's considered as one single channel. And DIMMs in channel B slot interact with these two right here. So if you go to here, so this one and this one will work together kind of things. And then, these two work together in this diagram. Sorry about that. And these two work together in this diagram. But on the actual physical board, it typically one after another. So basically you put it one card here and you put the next card here. So these two to work together. So if you're only going to populate in this motherboard, right, just 2 slots, you will be populating the very first one and the third one. You don't populate the second one because you're trying to populate the channel A first, then you're going to populate the channel B. If you populate the channel A slot and a channel B slot, the memory speed's gonna be slower. It's still gonna work. It's just not gonna be efficient enough because you're not populating one channel at a time. You're mixing channels, right? So keep that in mind. Three identical DDR3 DIMMs installed in a triple channel configuration is shown here. So what happened is, in this situation, the 4 slot is empty, and we are populating 1, 2, 3, so the first 3 slots. And in this here, if this motherboard support the triple channel configuration, and it will get the high efficiency that it needed to operate. So expect a motherboard that uses quad channeling to have 8 memory slots. So the 8 DIMM slots support 4 channels. That means each channel has 2 slots. The processor can address 4 slots or 4 channels at the same time. So that's what a motherboard with the quad channel support would do. To know which of the 8 slots to populate for optimum performance, again, you have to refer to your motherboard manual or the motherboard indicators, such as the coloring or the letter coding of your DIMM slots. So in here, I have a diagram of the desktop gaming motherboard on the left hand side, and a motherboard for a dual chipset or dual CPU image. So you can see this is the server board right here on the right hand side with the dual CPUs, server RAM, and here we have a single CPU desktop with the desktop RAM shown here. So this is shown here. So when you are populating this RAM right here, you have to refer to the motherboard manual and the configuration based on according to that motherboard manual. And same goes for servers. So it doesn't matter whether it's a server or desktop, you still have to refer to your server motherboard manuals and make sure you populate these RAM accordingly. So in here, in this image, all the RAM slots are populated, but if all the RAM slots are not populated, you will be following those motherboard instructions and populating those server RAM accordingly. DIMM speeds are measured in megahertz or cycles, right? So megahertz are basically cycles, and PC ratings. So those are like called PC ratings. You might see PCs dash something when somebody's describing to you it's RAM, like for example PC4-24000. Sometimes there is a dash here, sometimes they don't add the dash, but at the end of the day, like you will see that the PC ratings. So PC rating is a measure of the total bandwidth of data moving between the modules and the CPU. So to calculate the PC rating for a DDR4 DIMM, you basically multiply the speed by 8 bytes, because DIMM has 8 byte or 64-bit data path. So if you take this example for a DDR4 DIMM that runs at 3000 megahertz, has a bandwidth or transfer rate of 3000 multiplied by 8. So if somebody say you have a DDR4 modules at 3000 megahertz, you have to multiply that 3000 by 8. That will give you 24,000 megabyte per second, which can be expressed as PC4 24,000. So this can be expressed as PC4 24,000. A DDR4 PC rating is labeled as PC4, because if it is DDR4, we're gonna say PC4. So that's how the PC ratings work. So if you're gonna go out there and buy a DIMM module that has a bandwidth of 3000 megahertz, you're gonna get a DIMM module of PC4 24,000. So that's how you actually interpret the PC rating on a DIMM when you're purchasing DIMM modules. Error checking and parity. So error checking code, also known as ECC, is a important important thing for critical applications. That includes the network servers that have long used a special type of memory that is called ECC. So these are like, mostly the ECC is the memory. What you need to understand is used by servers. Those are like used in critical applications and network servers, and they have been in use for a long time, and they are basically called error correcting code or ECC. because this memory enables the system to correct single bit errors and notify you of large errors. So it increases the fault tolerance and detects and correct errors in a single bit. And it can detect errors in a 2 bits but cannot correct it, and it can correct the error in a single bit. So the applications that use ECC make 64-bit DIMM a 32-bit module, 72-bit module. So each ECC memory that is rated as 64 DIMMs, basically operating at 72-bit. Again, what really important here is the error correcting code type memory or ECC memory is used in servers, network servers, because servers has to have a very high fault tolerance to run its applications and serve its end clients. So you need to make sure that the ECC is enabled and ready to go. And almost every single server that you can buy in 2022 will have ECC memory. Even small business servers would use ECC memory. Now you may ask the question, if the ECC memory is so good and it's good for even any application, even if you don't use the enterprise grade applications, why don't we use it on desktop computers? The reason is the cost. The cost associated with buying or like manufacturing a ECC RAM is much higher than the cost of a desktop RAM. Desktop RAM, whether you are using for gaming or high-end applications such as AutoCAD or CAD design programs or video editing, 4K video editing, does not need the ECC, and it doesn't have any advantage of using ECC memory, ECC RAM for those kind of applications. So that is why we only use ECC or error correcting code memory on typical server environment, unless otherwise you are building a desktop computer using a server motherboard. So keep that in mind. Parity is used by older SIMs and uses error checking based on extra 9th bit. So odd parity, for example, a parity bit set to make odd numbers a number of ones, and even parity is a parity bit that makes the even number of ones. So the parity error is the number of bits conflicts with the parity in use. But keep that in mind, the parity is an older technology, older SIMs that most likely you're not going to come across in 2022. Before I move forward, I'm going to go back to mention something else. With respect to error correcting memory or ECC, another question that you might ask, why do servers actually need ECC at the first place? Why do server applications actually need ECC? What causes these single bit errors? So this is something a lot of people don't know, even computer engineers. I have met people who are working in the industry for a longest time, like the network analyst and server administrators and system analysts. They couldn't even explain what would cause the single bit error. The single bit errors or multi-bit errors in memory are typically caused by like electromagnetic waves or some kind of a electromagnetic, typically electromagnetic solar waves and stuff like that. So like all electronics in the world are affected by the sun, moon, and all those things. I know it sounds really mumbo jumbo science, but it is true. There is a tiny impact to all memory processing sequences because of these electromagnetic waves and the waves that caused by sun, moon, and other systems, right? So based on current understanding of our science with respect to memory, this is one of the primary reasons. The sun, moon, and other ray that caused by differences in electromagnetic waves on Earth is what actually causing the single bit errors in the memory, which is not a big deal on home computers, as I mentioned, but it can become a problem on servers, especially servers running like huge financial transactions, banking servers, etc., etc. Those things could have a significant impact in the long run. So if somebody asks you, why do you need error correcting code on critical applications? What causes those errors in the bits? It's mostly electromagnetic waves. So the current understanding is still an area of research still being done, but that's something that you should keep in mind. Buffered and registered DIMMs. So buffered and registered registers hold data and amplify a signal before data is written. So the primary function of a buffer or a register within the RAM module is to hold data and amplify the signal. So it can increase the memory performance in servers. Again, they are mostly buffered or registered DIMMs are typically used in servers, and most types of desktop memory modules use unbuffered memory because it's cheaper to produce, and the servers and some workstations use a type of memory called registered or buffered memory because that is needed for those particular applications. Buffered or registered memory contain a register chip that enables the system to remain stable with large amount of memory installed. The register chip acts as a buffer which slightly slow down the memory access. However, the buffered RAM can be built with or without ECC support, and most buffered memory modules are used by servers include ECC support. So keep that in mind. So the buffered memory will slow down a little bit, but it will result in the ability for the processor to hold large amount of memory. Like I'm talking about like 256 gigabyte up to 1 terabyte of memory on the motherboard. And buffered registered memory can be used along with the ECC support, but you do not necessarily need ECC when you are using buffered memory, right? Because the buffered or registered memory are commonly used in servers, typically ECC memory support is already there. So the error correcting memory and buffered RAM are typically a combination that you get together when you're purchasing server RAM, because servers need and servers usually use both of these technologies. Registered DIMM, also known as RDIMM, use those registered, while unbuffered DIMM do not have buffered or registered support. CAS, or Common Access Strobe latency, is a way of measuring access timing. So this refers to the number of clock cycles it takes to write or read column or row of data of a memory module. So lower the value of CAS are better for your system. So lower the CAS value, or which is a latency measure, the better that module going to be, the RAM module going to be. So the RAM modules adds, ADS adds, it provides a CAS latency value within the series of timing numbers. So like it will say something like 5-5-5-15, for example. So when you're trying to purchase a memory, you will have those CAS information either on the manual of that memory or on the stick. There will be a sticker with that information. So what is CAS? Now you know what is CAS. It's basically a way of measuring access timing, and the lower you can get these CAS numbers, the better for your configuration. Types of memory used in laptops. So we talk about desktops and we talk about servers, right? So let's talk about laptops. So today's laptops use DDR4, DDR3L, DDR3 or DDR2 SO-DIMM memory. So only use this type of memory the laptop is designed to support. So you need to make sure the type of memory that you're using on the laptop that is specifically designed for your laptop. Like what I mean is, it doesn't mean that if you have a HP laptop you have to buy HP RAM. What it means is if the HP laptop only specifically support SO-DIMM, you need to get that SO-DIMM, that particular module, because otherwise it won't fit in. The number of pins and the positions of the notches on the SO-DIMM keep you from inserting the wrong modules in the memory slot. So it will be a little bit harder to insert a incorrect RAM to a laptop. Because of the way it's designed, just like the desktop and servers, it has those notches and configuration just like the desktop, and the servers, so that you won't insert the incorrect RAM modules, right? You don't need to use force to install any of these modules. So keep that in mind. Be gentle, just like a RAM, baby RAM, be gentle with your, device RAM, your server, desktop and laptop RAMs. So if it doesn't fit, maybe you pick the wrong RAM. So just check everything. So be gentle, just like a baby RAM right here. Right? It's just another joke. So yeah, how much is too much RAM? This is a question that keep coming up in the circles of computer enthusiasts, especially gamers. But also this might be some one of those things that might come up in your management meetings when it's come to the point servers in the enterprise environment, as well as the end client devices in your company, right? So how much is too much RAM? Because the companies don't want to spend extra money for items that rarely been used or never been used by their end users or the company servers. So how do you going to decide? How do you going to recommend as an IT professional how much is too much RAM, right? So when deciding how much memory the system can support, as an IT professional, you shouldn't pick RAM based on based on your feelings. You know what I mean? Like, ooh, more RAM is better, bigger the better. No. What you need to consider is, from a logical and technical and scientific point of view, is the limitation of the motherboard, processor and operating system, the current baselines. So if you never heard the term baseline, the baseline in computers is basically you use certain tools or built-in tools such as Windows monitoring softwares that is already built into Windows servers and Windows computers to basically gather data for a month or a week or a few days at a time of when a typical user is accessing your server or typical user is using their computer. So even if you are building a gaming computer or home use personal computer, you can just take some data from their current computer and check the current baseline. So baseline basically give you the RAM usage, the CPU usage, the computer read and write cycles onto the hard drive, all of that information over a period of time, either for your end user desktops or laptops, or for your company servers. Based on that, you can decide whether your company or the end user need to have an upgrade of the motherboard or the upgrade of just the RAM modules on that motherboard, etc. The peak usage, that's another one that we use. How that gonna work is basically in a company or corporate environment, you will see how your end user client use Windows 10 Professional or Windows 11 Professional, for example, over a period of time, and you're gonna see how that's going to pan out with respect to all the hardware in use. So whether your end users are using all the RAMs available and hence causing high paging activities, causing the systems to bog down. In that case, you may have to increase the RAM. So that's how you have too little RAM in that situation. Paging activity, as I mentioned, goes up as the RAM is becoming insufficient for use case scenarios. So paging, we will go over a little bit of how paging works in the future lectures. Paging is both Windows and Linux machines and Mac OS machines do have paging, different types of paging methodologies, but they all have paging. What paging does is when a RAM is overused and there is not enough RAM to run all your applications currently running, it will page onto your hard drive. So your hard drive is going to be acting like a type of a RAM, but it's going to be highly inefficient RAM, and that hence the high paging levels indicates there is an insufficient amount of RAM on your device. So that's how you know there's too little RAM. The limitation when considering the OS includes like Windows 11, Windows 10, Windows 8, 7, etc. Require at least 1 gigabyte of RAM on a 32-bit installation and at least 2 gigabyte of RAM on a 64-bit installation. That does not mean that you should recommend your end user just 2 gigabyte of RAM because they have 64-bit Windows, because that's the minimum requirement. I would almost never install 2 gigabyte of RAM on a 64-bit Windows 10 or Windows 11 machine, because that is the minimum requirement. And nowadays his RAM is getting cheaper and cheaper and cheaper. I would go at least like 8 gigabyte nowadays. So keep that in mind. So just because of the lowest amount supported is 2 gigabyte does not mean that you should all go with 2 gigabyte. For 64-bit installation, Windows 11 and Windows 10 Pro can support up to 2 terabyte of RAM. That is the maximum upper limit. And the Windows 8 Pro can support up to 512 gigabyte of RAM. And Windows 7 Pro can support up to 192 gigabyte of RAM. However, as I mentioned, even if the end user use AutoCAD program for engineering designs, I have never seen anybody utilize at least 90% of 2 terabyte RAM when I use baseline on those end devices. I have never seen that. So it's really they're going to be a use case scenario of 2 terabyte of RAM on an end device. But it may be a case where you use 2 terabyte of RAM on ECC RAM on a server. So if you have an enterprise server, there may be use case scenarios. There are hundreds of users accessing the server and they are using high RAM usage applications. You may need to get close to 2 terabyte of RAM installed on the server itself. But it doesn't mean, it needed to, I don't know a use case scenario of 2 terabyte RAM on a desktop computer. So there is such thing called too much RAM, because you are wasting. If you install 2 terabyte of RAM on a end Windows 11 professional machine end user, and the end user only using like something like QuickBooks or simply accounting for accounting programs, something like that, you basically wasted your company's money on 2 terabyte RAM. That's an expensive waste of money, because the end user in the accounting department using QuickBooks will never use that 2 terabyte of RAM ever. So keep that in mind. A 32-bit Windows 10, 8, 7 installation can only support up to 4 gigabyte of RAM. Nowadays, I do not recommend anybody installing 32-bit versions of any operating system where 64-bit version is already available in the market, because most of the newer even hardware nowadays are specifically configured to run on 64-bit for higher efficiency, and therefore I would recommend that you always pick the 64-bit versions whenever possible. So here is an example of how you can check current RAM usage. This is just a simple task manager would show you your server or your end device RAM usage. So right now I have a Windows Server 2019. This is a configuration that I have done, and I have 72 gigabyte of RAM installed on a Intel Xeon E5649 processor, and I have 2 processors that is sharing this 72 gigabyte of RAM half. So I have populated the 2 processors evenly distributing the RAM, and these are ECC buffered RAM. And on current usage of this server, I see that only 23% of the RAM is used. And this doesn't necessarily mean that I have overkill this this server configuration with the too much RAM installation, because this is an instant at time that I took a screenshot of the task manager for that server, which is currently using 23% of its 72 gigabyte of RAM. It's only using 16.3 gigabyte of RAM. So as my family members and all the other users and friends are accessing this server, as they're accessing also through remotely as well as inside my house, the RAM usage gonna go up, and that's why I have 72 gigabyte of RAM, because I have run some Windows monitoring devices and monitoring software to look at the how RAM usage work throughout the day and week and months. So I will show you how you can do that on a separate video and a separate lecture. For now, just remember, you can just quickly check current RAM usage by just opening up the task manager and going to the systems information. You can see how much RAM is installed and what processor and all the other information. And on the task manager, you can see how much RAM is installed and what's the speed of that RAM and how many slots are being used and how it is being currently used. And another key piece of information you can get out of the task manager is the use of paging. So it shows the page pool is 1.2 gigabyte, but non-page pool is 465 megabytes. And you can see, how the paging is being used currently on the task manager as well. Again, I will go into depth of how you can use this information and what this information means on a separate video. How much is too much for a server? So the previous one we look at generally the desktop computer, but I did go over a little bit of server. So here is a summary of what I just discussed. So servers usually have more RAM than your typical desktop. So as I mentioned, you need to consult with your management team, IT department, leaders, it could be team leaders or management leaders or end client on the requirements each situation present in order to determine server RAM configuration. So you need to meet with your management team, IT departments and everybody, and make sure that everybody on the same page and the requirements to determine the server RAM configurations. For better performance of your Intel and AMD server motherboards, it is generally recommended to populate as many RAM slots as possible, as opposed to using high capacity RAM with less slots populated. This is just a rule of thumb that I've been told by my instructors and my professors at the university, but this rule of thumb may change as the technologies are changing. So keep that in mind. Take that as a grain of salt, but for now, it is generally recommended to populate as many RAM slots as possible. So what that means is basically using 16 modules of 4 gigabyte ECC RAM with highest frequency may be a better option compared to populating a server with 8 modules of 8 gigabyte of ECC RAM with a lower frequency than what you could get with the 4 gigabyte ECC RAM. So both will give you 64 gigabyte of ECC RAM, but with having 16 modules of 4 gigabyte high frequency ECC RAM may be the better efficient system when you're building. So think about that, and again refer to your motherboard manual is what is the best option, but this is just a rule of thumb that we generally use with servers. Selecting the right RAM modules. So read the motherboard documentation, which indicates how much memory the motherboard can physically hold. DIMM modules can be installed as a single modules, or it may support dual or triple channeling. And when there is channeling support, install matching DIMMs in each channel for best performance. So as I mentioned before, when we discuss about channeling, when you have dual or triple channeling, make sure that you match the DIMMs in each channel for the best performance. I would buy the DIMM modules from the same manufacturer with the same frequency and same model number, even same batch number if possible. Motherboard using DDR3 triple channel DIMMs, use 3 matching DIMMs in the 3 blue slots. If the 4th slot is populated, the board reverts to a single channeling. So keep that in mind. So if you have a motherboard with triple channel support in DDR3, if you have 4 slots, if you populate 3 of them, it will work in triple channel mode. That may be better efficiency than populating all 4 slots, because that's going to revert the entire motherboard configuration into single channeling mode. In dual channeling, install 2 matching DIMMs in 2 blue slots furthest from the processor. Leave other 2 slots empty. So the term blue slot may be red slots or maybe green slots. So the color of the slots may change. I don't know why CompTIA manuals sometimes, the books keep saying blue slots. It could be any colored slot. So basically colored slots furthest from the processor should be installed first and then leave the other slots empty. For one installed DIMM, place it in the blue slot or the colored slot furthest position from the processor. That's the typical configuration of installing RAM modules. Motherboards using DDR3 triple channel DIMMs continues. So that is continues from whatever we are discussing here. So this is all part of the triple channel DIMMs, by the way, just in case you missed that point. So these are all part of the DDR3 triple channel DIMMs options. When serial present defect, also known as SPD, the DIMM technology, it is a type of DIMM technology that declares module size, speed, voltage, and data path with to system BIOS at startup. So today memory always support SPD. So it is typically present in these type of DDR3 triple channel motherboards. So the SPD is typically enabled and it's being used on these type of motherboards. Compromise if the exact match is not available. So mixing unbuffered memory with buffered or registered memory will not work. So if you mix buffered and unbuffered memory, your system not going to recognize those RAM and you're going to have a problem. However, match memory modules manufacturer if possible. In a pinch, try using memory from two different manufacturers is okay. However, but it is recommended that you're using the same manufacturers and even the same batch number for servers for high efficiency, in my opinion. If mixing memory speeds, all modules perform at the lowest speed denominator. In other words, what that basically means is if you have mixed speed RAM modules, the lowest speed RAM modules going to dictate the speed for the entire set. So if you have 8 RAM modules and one of them have like 1200 megahertz and the other one is 3600 megahertz, the 1200 megahertz going to be the speed that all of those 8 sticks going to run, even though the other 7 sticks are at a higher rated, because the lowest speed denominators, lowest speed RAM modules gonna dictate the RAM speed for all the RAMs in your configuration. So keep that in mind. Use a website to research your purchase. So look for search utility matching modules for your motherboards. Some companies such as Intel actually do have their own websites where you can actually figure out best matching options. So make sure you use those sites. Some companies may also have, such as the vendors or the outlets may have websites where you can configure your RAM before you purchase it. So use those search utilities to make sure that you purchase the right RAM and the right configuration for your motherboard. So what really important here is remember that there are many types of RAM. Remember we discussed DDR3, DDR2, DRAM having different notches. So on the right hand side you can see that those different notches in a diagram. So the DDR3 have a notch right here and the DDR2 notch right here and the DDR notch right here. So that's why they are not interchangeable. So even if you purchase a DDR2 RAM for a DDR3 motherboard, you won't be able to insert that RAM because the notch is in the wrong place. So please don't try to force insert it. And if you look at different types of RAM on the left hand side, here is many different types of RAMs that you can get in the market right now. It starts from 30 pin all the way to 240 pin DDR3 RAMs is shown here. The DDR4 RAM also not shown here in this slide. It would have a different configuration as well. So keep that in mind. Remember, there are many different types of RAM and it is important that you purchase the correct RAM or you'll be wasting time returning those RAM or exchanging those RAM when you try to put your systems together. So here is a type of a website that I use. It's Memory Express, which is a Canadian website that I would recommend because they have good customer service and they have a good collections of locally available RAM. So like I can basically walk into these Memory Express stores in Alberta, for example, and I can just get it from the Canadian company. And on their website, you can see this is the laptop RAM, and the laptop RAM have different configurations like PC4 25600 and PC4 21300. So this is different from this one. Both are PC4, but they have different speeds and different configurations. And this one, all of these ones are showing as actually one module. So it says 1X. But if you go to this one, the desktop RAM, you see some of them say dual channels right here, dual channel 2x 8 gigabyte. That means these two are frequency match and batch match. So this is probably coming from the same batch of RAM. So if you buy this dual channel 2 RAM, I would put them in together in that dual channel configuration. I wouldn't buy one from here and then let's say one from here and mix them up. So I wouldn't put it in a dual channel, one of this and one of that. Instead, I'll buy a package like this because I know the lot number going to be the same and the frequency going to be the same, and they're properly matched and they are both from the same manufacturer, and I will install it. So this one has 2 8 gigabyte of stick. This one also have 2 8 gigabyte of stick, but I would not buy these two and then mix them up. Instead, I would buy this one, 2 8 gigabyte of dual channel, and install it. And then in the future, I may buy this one and install it in the next dual channel, but I'm not going to mix them up. But what would be better with buying two of these, or buy a quad channel package for Corsair in this case, and then installing them on your motherboard. So this is an example of that showing. And again, it shows that typically laptop memory do not have those dual channel etc, or especially not the quad channel that you can purchase. The form factor is also different, while the desktop memory you do comes with this dual channel as well as single channel memory module. So you can see that in here. And prices, don't pay attention to prices because they always change. I recorded this video in 2022 July. So if you recorded this video in a different time, the prices may have changed. So this is the prices currently in the Canadian market in Alberta that you can get in 2022 July, right? So keep that in mind. Prices do change. In terms of performance comparison of RAM types, these are RAM types all the way to DDR4. And you can see the performance listed on this table. So the SD RAM first came out in 1993, while DDR4 came in 2014, and there are iteration in between. And you can see the bus clock have changed significantly, keep going up each time. And also data rate has significantly increased compared to SD RAM all the way to the DDR4. And you can also see the voltage use have changed, varies depending on the RAM. DDR4 is not only a faster data rate, higher transfer rate, higher bus speed, but it also uses less power, less voltage than SD RAM. SD RAM was 3.3 volts to run, and this one only need 1.2 volts. That is extremely energy efficient, and at the same time have a higher data rate. So that's what is showing on this performance comparison of RAM types. But keep in mind, if your motherboard only support DDR3, there's no way you can install DDR4. So you have to replace your entire motherboard to get these type of efficiencies and get better RAM, right? Keep that in mind when you are installing RAM. That is always needed to be taken into consideration. Your motherboard has to support it, right? So keep that in mind. So let's look at how we can populate or replace your RAM. In other words, install or replace your RAM. So RAM is one of the components that is extremely sensitive to electrostatic discharge. RAM is one of the components on your motherboard that could fry up because of a electrostatic discharge. So make sure you use precautions to prevent electrostatic discharge on your RAM modules. So how you do that is to using anti-static wrist strap. Looks like this. They are extremely cheap. RAM is expensive compared to this cheap electrostatic strap, especially if you're installing ECC server RAM. They are extremely expensive compared to this strap. So please go ahead and buy that anti-static wrist strap. Plus, there are ESD anti-static floor mats typically used in companies, in server rooms, etc., which try to dissipate the ESD. But even if you use an anti-static floor mats, I would still use anti-static wrist straps, because that will provide better dissipation of the electrostatic discharge without damaging your electronics compared to an anti-static floor mat. So you can use anti-static floor mat, but along with the anti-static wrist strap. But always I would recommend that you use an anti-static wrist strap. RAM is extremely sensitive to electrostatic discharge, and you can actually destroy your RAM, and there is no way that you can actually repair it when you destroy your RAM, because RAM is very compact modules and they are not repairable if there is electrostatic discharge. Make sure you turn off your power to your server or the PC, unplug the power cord, press and hold the power button for a few minutes so that the power will go out from any remaining components. And one note on that, some motherboards, especially some server boards do have a LED light that actually tell you if all the power is drained out. So keep holding that power button after you unplug the power cord until that LED power light goes out, or just hold it for a few seconds if you don't have that light in most desktop computers, for example. Then we're gonna remove the case cover. Then handle memory modules with care, with electrostatic anti-static wrist straps, and maybe even gloves, and be careful with touching the memory modules, those pins, because you don't want to short them out either. So that's why it says do not touch the edge connectors on memory modules or memory slot, because that could create a short circuit. Do not stack cards or modules. Well, I've seen even IT technicians with a lot of experience stack their modules on top of each other. That is a bad idea. It's okay maybe if you have something in between each of those modules, like some kind of a anti-static paper, like a foam or something like that. But other than that, do not stack on top of each other. That is a bad idea. During transportation, you may stack memory modules, but it should be done according to manufacturer standards and whatever anti-static covers in between. So keep that in mind. And look for notches on the side or in the middle for correct orientation. So remember the RAM modules have those notches, right? In the previous one I show you these are these notches. So if, for example, DDR3, if you flip this thing around and try to insert it, it's not going to go in because the notch is going to be in the wrong place. You have the correct RAM, your motherboard does support DDR3, but you need to also align this notch in the correct orientation in order to go in. So don't force it in. So just make sure that the notches are on the right side before you're trying to push it down. So pull out supporting arms on the side of the slot if you are pulling out a DIMMs. So make sure these are the clips that hold the modules, these plastic clips. So you need to push it away from your module on both sides, and it will pop this thing out. And use notches on the DIMM edge connector as a guide. So the notches on the edge of this can work as a guide for you, and insert DIMM straight down into the slot. Sometimes I've seen people insert one side first and then insert the next side. That's a bad idea. You should always do it straight down. And when you're trying to insert it, make sure these clips are open and empty. So they're open in, like, don't have this thing closed. It has to be open. And when you push it down straight down, it will click into place. It will close itself when it's properly seated in this slot. So when the DIMM is fully inserted, the supporting clips should pop back into place, and you don't need to do anything about it. It will automatically click in. But however, sometimes this may not get fully closed properly. So make sure you push it down carefully but firmly until these pins are closed, and make sure they are closed properly and the RAM is seated properly, because otherwise when you boot up, you might get a RAM error. And when you can enter the BIOS or UEFI to verify that memory is recognized and there are no RAM errors, if the RAM error didn't pop up on your screen, if it is not properly seated, right? You can always check the UEFI BIOS. So if you have installed, let's say 16 gigabyte of RAM or 265 gigabyte of RAM on a server, for example, and it is only recognizing 72 gigabyte of RAM, probably you didn't insert it properly or you have a bad RAM module. So make sure you check those out. Most modern motherboards have 2 or 4 memory channels. Remember those dual channel, quad channel configuration. So to use multiple channels, you need multiple RAM sticks. They should be installed so that you have at least one stick in each channel. So check your motherboard manual for configuration and check your motherboard for the slots that are usually color coded, and follow those color coding accordingly. And however, as I mentioned, the color coded is not always the case, so you always need to refer to the motherboard manual to make sure you follow the correct configuration. So likewise, I said it could be green color coded, blue color coded, red color coded, yellow color coded with black as a complement color, but it depending on the motherboard, it's gonna change. So on the left hand side, I found this diagram somebody made who is trying to mix and match their memory modules. So he has 2 gigabyte of RAM and 4 gigabyte of RAM, and the mixed RAM 6 gigabyte per channel in here. And here what we have is the matching RAM, where one channel have 8 gigabyte, the other channel have 4 gigabyte. So this one, each channel have 60 gigabytes because one channel have 2 and 4 and 2 and 4. And in this configuration, he's showing here that you have one channel with channel 1 with 8 gigabyte because we have 4 and 4, and the other channel have 4 gigabyte because we have 2 and 2. So you can populate if your motherboard is supporting it. So simply put, the memory channels are links between your RAM and your CPU through which data moves between the two, right? So simply put, the memory channels are basically a links between your RAM and your CPU. So these channels, what they are going to do is, instead of this RAM is working independently with against each other, they are actually working together in tandem. That's what the channels are doing. So what is basically doing, it is moving data between the two RAM, but the CPU try to look at those RAMs as a one single unit, even though there are two RAM modules installed, because it's in one channel. So if channel A gonna look at the RAM in one single unit. So the RAM is the computer's short-term memory, and the CPU is the main processor that does stuff with the information in the memory, and the RAM channels are how that information moves back and forth. So let's say this manufacturer of your CPU with potentially many factors, right? The manufacturers of your CPU consider many factors, such as the cores needed for the materials, makes the order of the materials from only supply of the memory channel, right? What I try to say is that the CPU manufacturer and the motherboard manufacturer have to take into consideration multiple factors when they decide how these dual channels and quad channels and triple channels going to work. So that includes the CPU manufacturers, the chipset manufacturers, the processors that it can support, and bus speeds and everything. And that would actually dictate how your motherboard manual gonna tell you, how the motherboard will be configured to support these dual, multiple, and quad channel, those memory support, right? Keep that in mind. And sometimes these memory modules have these LED lights in between that will actually tell you if you properly populated the RAM as well. So that's what I'm trying to tell you. I don't want to confuse you here right now, but yeah, so the way that the memory channels, which links between your RAM and the CPU, through which the data moves between those RAM modules, works depending on the CPU, chipset, and many other factors. And that's why you need to refer to your motherboard manual to make sure you follow proper guidelines and the instructions. So we're going to switch gear to server RAM configurations. So again, just like the desktop motherboard, you had to refer to the manufacturer guidelines for installing server RAMs. It is recommended to populate each RAM bank for each of the installed CPU with as evenly as possible as unless otherwise noted by the manufacturer. So what that basically means is if you have a limited number of RAM modules, please populate your RAM accordingly. If you have 2 CPUs installed on your motherboard, for example, in this Intel server board 2600 family, if you have 2 CPUs installed, but you don't have enough RAM to populate all of these RAM slots, please try to evenly distribute your RAM between the CPU 1 and CPU 2 RAM banks, because that will maximize your ability to get the maximum out of your RAM modules. That will give you the best performance. But if you have the ability to populate all of these slots, yeah, just populate all of these slots. If you have only one processor installed, then you only have to worry about populating one of the, only the RAMs associated with this CPU 1. And it is important, if you are installing one CPU, you want to install on CPU 1 slot, not on the CPU 2 slot. Again, refer to your server's manual, how you can install one CPU on a multi-CPU, like a dual or quad CPU configurations, right? Keep that in mind. So each processor can, however, access each other's memory, but the performance will be significantly degraded if the accessing memory on the slot for a different processor. This is called non-uniform memory access, also known as NUMA. So that's what could happen if you populate memory unevenly across 2 CPUs or multiple CPUs, or you do configuration incorrectly. So keep that in mind, right? So each processor, so if you install 8GB of RAM here but 24GB of RAM here, this processor can access, when it's run out of RAM on its banks, it can access the memory from this bank, from the CPU 2 bank, because the CPU 2 have 24GB of memory and this one only have limited memory. It can access it, but however, that's going to result in non-uniform memory access, also known as NUMA. I'm not going to go into detail on non-uniform memory access with multi-CPU server boards in this lecture, but I might talk about that in an advanced lecture on RAM later sometime. But keep that in mind. It is always recommended to populate RAM banks for each of the installed CPU evenly as possible whenever you have multi-CPU server boards, because otherwise it will result in non-uniform memory access, which will significantly hinders the performance of your server. So keep that in mind. Again, whenever you have a server configuration, refer to the manuals, and the manuals will have this type of tables. Typically, somewhere in the manual, this is again the Intel server board 2600 family, and this shows when you have the ability to put 2 CPUs, so CPU 1 and CPU 2. I don't know why they call it MC0 here. Maybe this is CPU 1. So again, I had to refer to the manual, right? So manual will give you a table like this, and it will tell you how you can populate limited number of RAMs. So if you have all the RAM sticks available to populate every single DIMM slot, you can just populate everything out. It's no problem, right, on the slots. But if not, you have to follow a table like this. So in this particular Intel server board, they also give you some bullet points instructions. I copied directly from the Intel server board, this particular server board manual posted on this website. You can go here, right here. It's displayed on your screen right down here. And it says, hey, each installed processor provides 6 channels of memory. Memory channels from each processors are identified as channel A through F. On your processor board itself, it actually will have these letters A through F sometimes. It printed onto the board sometimes. So DIMM population rules requires that DIMMs within a channel be populated starting with the blue DIMM slot or DIMM furthest from the processor in a fill furthest approach. So Intel is using the standard approach to populating DIMM, and they're selling that information to you. They're telling you that in their manual. When only one DIMM is used for a given memory channel, it must be populated in the blue DIMM slot furthest from the CPU. For best system performance in dual processor configuration, install DIMM type and populations for DIMM configured to CPU 2 must match DIMM type and the population configured to CPU 1. So Intel is telling you how you can get the best performance in the dual processor configuration right here. So even the manufacturer give you guidelines on that. Mixing of DDR4 DIMM types such as RDIMM, LRDIMM, 3D, SE-DIMM, etc., within or across processor sockets produces a fatal error halt during memory initialization. So that means when you boot up, your BIOS gonna initialize the memory, and you're gonna end up with the error if you mixing these DIMM types. It tells you that in the manual. Mixing DIMMs of different frequencies, however, and latencies is not supported within or across processor sockets. So if a mixed configuration is encountered, the BIOS attempts to operate at the highest common frequency and the lowest latency as possible. So in this Intel Server 2600 family, if you mix them up, what's going to happen in the frequencies, the BIOS going to attempt to operate at the highest common frequency and the lowest latency as possible. It is not recommended, but there are maybe situations where you're using whatever the RAM available in your company, and you may have to do that in your inventory limitations, right? So that is something to take into consideration. Here's a quick overview of replacing or populating the laptop RAMs. Upgrading memory on a laptop or even a mini compact computers is similar to that of upgrading memory on a desktop or a server. But however, there are few extra considerations that you need to take into account, and that is that you need to make sure the warranty is not being voided, because laptops oftentimes have special warranties that as soon as you open the backside of the casing or something like that, you void the warranty. So keep that in mind. Search for Best Buy on a suitable and authorized part. So search for the best possible purchase that you can make, not the Best Buy store, by the way. Here we are talking about the best. Search for best purchase you can make on a suitable and authorized part. General steps include decide how much memory to upgrade, then you're going to purchase the memory, and you're going to follow the similar step to install it. Make sure you use the anti-static strap, and make sure you be careful with the not touching the pins and of the memory, etc., etc. And be sure to match the type of the memory to the type of the laptop memory that which is support, because again, laptop motherboard has to support the memory that you are purchasing. And that would bring us to the end of this lecture. If you like these type of lectures, please don't forget to thumbs up and subscribe to my channel. Until next time, good luck with your exams and studies, and have a nice day.